On the roof there you see that's my 250 watt solar panel that I bought online. I'll show you where the power goes to that. Alright, so we're now inside the solar shed. So the power's coming in through here, through these cables, all the way into this meter here. Now what these are, I bought these on Amazon. These are basically watt meters, so they show you your current, your voltage and your wattage. So that's the current wattage being drawn from the panel. And that goes into this, which is a pulse width, sorry no it's not, it's a multi-point tracking charge controller. So what that does, that optimises the load of the panel to be as efficient as possible. And then it goes back into another watt meter, so you can see the power coming out of the watt meter, and that's the power going into the batteries, that's charging the batteries up. And that's connected to a set of batteries that's underneath here. I've got two marine lead acid batteries, giving a total of 24 volts. The reason I chose 24 volts is the higher the voltage, the more efficient the system is because you draw less current. And then here I've got a 24 volt to 12 volt converter. And the reason I've done that is to run normal car appliances, so things like you plug in your cigarette lighter. It gives me more options to choose from. And then connected to this I've got a standard modified sine wave 12 volt AC inverter. And this is connected directly to the batteries. This is a 2 kilovolt, so that's the kilowatt, that's 2000 watt, 24 volt pure sine wave inverter. The reason I've got the two is this one's recently got a bit damp, so I've got to try and fix this. And also it gives me more option because this one's more efficient, I found, in the long run. So this is useful for light loads, this one's useful for heavy loads. And on top of on the output of the DC-DC converter, I've added a bank of 10 farad, 6 10 farad capacitors. That's because I found that this can't take peak currents very well. So if you put a highly inductive load on there or something, it struggles and overloads. So the bank of capacitors there are to bridge the gap, so to speak, when you put a high inductive load on there. So far I found this system works quite well actually. Currently I've got a set of lights hanging in the shed. These are simple 12 volt car headlights that have been sitting here running. They're pretty much on all the time. They virtually take no load. I think they're 3 watts each, so they're taking virtually no load from the solar panel. Bear in mind it's a 250 watt solar panel. Currently we're drawing 22 watts, but again that's because the batteries are pretty much fully charged now. In fact they are fully charged, you can see from here. Battery voltage is nearly 29 volts. So we are fully charged batteries, and I found this system runs very well actually. I do have this connected to the house, so you see on that cable here, it runs down and out of the solar shed, and that runs all the way down the garden into the house, and I'll show you that in a second. So here we are, back inside the house now. You notice this is the plug socket that comes into the house from the solar shed. If you notice on the side I've got a switch fitted here. This switch is wired directly to the on switch on the inverter, so I control the inverter directly from here. And then to prove it, I've got my funky plasma ball, so I flick the switch, you should see the ball turn on. There we go. So that is a solar powered plasma ball, what everyone wants. There you go. Now the reason for carrying out this project is I want to prove that solar power can be viable in the UK, because I live in Kent in England. So admittedly it is the sunniest part of England, but given the winter we've had, it's not very sunny. So yeah, if we get any likes or comments for this video, I might give you some more information on it. Right, thank you very much.